Swayam Prabha. Digital India. Educated India.
Welcome you back. If you remember, in the last lecture we started the half range Fourier sine series and Fourier cosine series, and what is the Fourier series expansion for half range series, that we have observed. We did one example also. Now, let us take another example, so that you can understand it in much better way. Suppose we have to prove that f x equals x can be expanded in a series of sine in 0 to pi. Earlier problem what we did, that was from 0 to 2, it was there. Now, we are telling we have to expand f x equals x in as a cosine series in 0 to pi, and we have to show x equals pi by 2 minus 4 by pi into cos x by 1 square plus cos 3 x by 3 square, like this way also it will go. And from here we have to prove that 1 by 1 square plus 1 by 3 square plus 1 by 5 square, like this way, this is equals pi square by 8. So, to solve this problem, let us start with, and of course, one more thing on the same problem we will do it. Let me show the example first. So, this is the first part we will show, and in the second part same problem we want that f x equals x should be expanded as a series of sine in 0 to pi, and then we want to deduce the value of this series 1 minus 1/3 plus 1 by 5, whose value like this will be equals to pi by 4. So, you see, same function we want to express as a sine series, as a cosine series, and from there we will get different series. And please note that whether I am defining it as a sine series or I am defining it as a cosine series, the nature of the function f x equals x in 0 to pi will remain unaltered or will remain same. So, how to find the solution? Solution of the first part, that is f x equals x, we want to define as a cosine series. We want to express as a cosine series in 0 to pi. So, in 0 to pi means there will be a 0 will be 2 by pi 0 to pi f x dx, 2 by pi, this is equals 0 to pi f x is x in 0 to pi dx. So, that the value you will obtain as pi. Your a n is equals to 2 by pi 0 to pi f x into cos n x dx, you know it already, and this is equals 2 by pi 0 to pi, again f x is x. So, that x into cos n x dx. So, if you evaluate this integral, you will obtain 2 by pi minus 1 to the power n minus 1 by n square. So, that if n is even, the value will be 0, if n is odd, let us see. So, your a n will be, if it is odd, minus 2, so it will be minus 4 by pi n square whenever n is odd, and the value will be 0 whenever n is even. From here, so I obtained the value of a n as minus 4 by pi n square when n is odd, and it is 0 whenever n is even. So, that now f x equals x, this in 0 to pi we can define as a cosine series as x equals pi by 2 minus 4 by pi summation n equals 1 to infinity cos of 2 n minus 1 into x by 2 n minus 1 whole square. Or if I break it in individual terms, I can write down 4 by pi into cos x by 1 square plus cos 3 x by 3 square plus cos 5 x by 5 square, like this way it will go. So, this is the Fourier cosine series of x in 0 to pi. And next was I have to find out the value of this series 1 by 1 square, 1 by 2 square, 1 by 1 square, 1 by 3 square plus 1 by 5 square like this. And the cost term I have to make 0. So, if I put x equals 0 in this given series, I am putting x equals 0 in this given series. So, left hand side will be 0. This is equals pi by 2 minus 4 by pi into this is nothing but 1 by 1 square plus 1 by 3 square plus 1 by 5 square, like this way it will go. So, that you can write down 1 by 1 square plus 1 by 3 square plus 1 by 5 square like this. This is equals to pi square by 8. So, the value of the series is pi square by 8, this is equals to this, and this is the completeness of the first one, that is express f x equals x in 0 to pi as a in terms of cosine series, which we have defined here, and then we have found out the value of this series as pi square by 8. Next, the same function f x equals x in 0 to pi we will define, we will express it in terms of sine series. So, to express in terms of sine series, there will be only sine terms. So, that this is the solution for the second part of the problem, where I have to define f x equals x as a sine series in 0 to pi. So, that the term will be only b n. So, b n equals 2 by pi 0 to pi f x into sin n x dx. Your f x is x. So, that 2 by pi 0 to pi x sin n x into dx. Once I am getting this, if I evaluate, I will obtain minus 2 into minus 1 whole to the power n by n. My b n will be this one. Therefore, sine series of f x in 0 to pi is x equals 2 into summation n equals 1 to infinity minus 1 to the power n plus 1 into sin n x by n. And if you break it again, if you substitute the values of n equals 1 to 3 like this. So, it will be sin x by 1 minus sin 2 x by 2 plus sin of 3 x by 3, like this way it will go. So, this is the sine series of f x equals x in 0 to pi. Please note, although we are expressing f x equals x once as a cosine series, once as a sine series, they are two different series, but their nature, their graph will remain same in 0 to pi. Please note this thing. Now, we have to find out the value of this series, that is 1 minus 1/3 plus 1 by 5, 1 by 5, like this way, the value of what is the value of this series. So, this value if I want to get, I have to check what value I should put for x. So, here the value of x I should put on this is x equals pi by 2, then only these values will become 1. So, that now at x equals pi by 2, if I substitute, then I will obtain pi by 2 equals 2 into sin pi by 2 by 1 minus sin pi by 2 plus sin 3 pi by 2 by 3, and like this way it will go on. So, that which is nothing but 2 into 1 by 1 minus 1/3 plus 1 by 5, and like this way we will continue. So, the value of the series 1 minus 1 by 3 plus 1 by 5, like this way, this is equals to pi by 2 will go down. So, it becomes pi by 4. So, this is the value of the series, and the first one was the sine series expression of f x equals x. So, if you see once that was the original problem. First we are finding out f x equals x in terms of the cosine term. So, a naught will be there, a n will be there, you are evaluating the a n and ultimately you are obtaining a n equals minus 4 by pi n square when n is odd, 0 when n is even. So, that Fourier's cosine series of f x equals x in 0 to pi is given by this expression pi by 2 minus 4 by pi into this summation. And this I evaluate, this will be pi by 2 minus 4 by pi cos of 1 square, cos x by 1 square, cos 3 x by 3 square, like this way it will go. If I put x equals 0 in the series, I will obtain 0 equals pi by 2 minus 4 by pi into 1 by 1 square plus 1 by 3 square, like this. So, that the value of the series 1 by 1 square plus 1 by 3 square plus 1 by 5 square equals pi square by 8. In the same way, for the second problem, that is where I have to declare f x express f x equals x as a sine series, there will be only b n terms. So, b n will be equals to 2 by pi 0 to pi f x sin n x dx. So, I am getting the value of b n is this. So, sine series of f x equals x. If I expand it, I will obtain x equals 2 into sin x by 1 minus sin 2 x by 2 plus sin 3 x by 3, and like this way I will continue over there. At x equals pi by 2, if I put, I will obtain this expression where these sign terms all will be 1. So, that value of the series 1 minus 1/3 plus 1 by 5, like this way value of this series will become pi by 4. So, now I hope it is clear how to find out the half range sine series or cosine series of a function. Let us do one more example, so that you will understand it much better way. Now, let us take a function f x equals x square and we in 0 to pi, and this we want to express as a half range cosine series, and then we want to find the value of 1 minus 1 by 2 square plus 1 by 3 square minus like this. So, your f x is given as x square. So, your a naught is equals to 2 by pi 0 to pi f x dx. This is equals 2 by pi 0 to pi x square into dx, and this is equals 2 pi square by 3 we are getting, and a n similarly 2 by pi range is 0 to pi. So, we are writing 0 to pi f x into cos n x dx. This again 0 2 by pi 0 to pi, your f x is x square. So, that x square into cos n x dx, and you can write down this one as 2 by pi. If you evaluate the integral, x square sin n x by n plus twice x cos n x by n square minus twice sin n x by n cube. If you evaluate this integral, 3 terms will be coming by integration parts. By parts we can get it 0 to pi. If you put the limits over here, you will obtain 2 by pi into 2 pi cos of n pi by n square I will obtain. Cos n pi is minus 1 to the power n. So, that I will obtain pi will be cancelled 4 into minus 1 to the power n by n square. So, a naught is this one, a n is this. The function f x is an even function, therefore, I can expressing it in terms of the cosine series only, b n term will not be there. So, once I have obtained a naught and a n, then I can write down f x equals, which is nothing but x square, and x square equals a 0 by 2 plus summation n equals 1 to infinity a n into cos of n x only will come, n pi x by L actually, L is equals to pi. So, pi will be cancelled and this will be only cos of n x, summation n equals 1 to infinity, sorry, a n into cos n x. Your a 0 value we know the a n also. So, that if I substitute n equals 1 to infinity minus 1 to the power n by n square into, there will be the term of cos n x. And if I expand it, then I will obtain pi square. This is equals to pi square by 3 minus 4 into cos x by 1 minus cos 2 x by 2 square plus cos 3 x by, like this way we will go. So, our expansion is f x equals pi square by 3 minus 4 into cos x by 1 minus cos 2 x by 2 square, like this way. And also we want to find out the value of this 1 minus 1 by 2 square plus this series. This is equals how much? Obviously, I will obtain this series if I put x equals 0. So, on this function x square equals pi square by 3 minus 4 into cos x by 1 minus cos 2 x by 2 square, like this way. If I put x equals 0 on this series, so at x equals 0, what I will obtain? I will obtain 0 is left hand side, pi square by 3 minus 4 into 1 by 1 if I am writing minus 1 by 2 square, like this way. So, that the value of the series 1 minus 1 by 2 square plus like this way is nothing but it will be pi square by 12. So, this is the expansion. Now, just let us go back quickly. So, for this series a naught a n we are finding out. After finding out a n we are getting this value 4 into minus 1 to the power n by n square. So, that we are writing the series like this way, and if I express it will be this series. To get the value of the required series 1 plus 1 by 2 square minus 1 by 3 square, like this we are putting x equals 0. So, that the value of the series is 1 minus 1 by 2 square plus 1 by 3 cube, like this way the series is pi square by 12. Let us take one more example. Expand f x equals cos x as a half range sine series. Please note, we want to expand it as a half range sine series. So, half range sine series of f x is, we can write down summation n equals 1 to infinity b n into sin n x b n into sin n x, where your b n will be equals to 2 by pi. This is defined in 0 to pi. So, it will be 0 to pi f x sin n x dx. Value of f x is cos x. So, that this will become cos x into sin n x dx. So, this is simply cos x into sin n x dx, and already we have done the result of this. What is happening? Sorry, here it is, I have to make n equals 1 first. What is b 1? That let us check. Your b 1 will be equals to 2 by pi 0 to pi cos x into sin x dx. I have to make it for n equals 1. What happens for n equals n greater than 1? What will happen? That I have to check in this case. So, it is b 1 from here 2 by pi 0 to pi cos x into sin x dx. So, that this equals, you can write down 2 by pi into, this will be sin square x by 2, 0 to pi. So, sin 0 0, sin pi 0. So, the value is 0. Therefore, from here we are getting B 1 as 0. Now, let us see for n greater than 1, what is the value of B n. So, whenever for n greater than 1, what happens? Your B n will be from the formula, I can write it 1 by pi 0 to pi. This will be sin of n plus 1 into x plus sin of n minus 1 into x into dx. So, that you can evaluate it easily. The result of evaluation integration will be minus cos of n plus 1 into x by n plus 1, sin n plus 1 is there, minus cos of n minus 1 into x by n minus 1, 0 to pi. And this equals, you can write down 1 by pi into minus cos of, if I put the value n pi plus pi by n plus 1, minus cos of, this will be n pi minus pi by n minus 1, and for 0 it will be plus 1 by n plus 1 plus 1 by, this is 1. So, it is 1 by n minus 1. So, if I put the limits of these two, then I will obtain this one. So, that from here again I can simplify it and I can obtain B n equals 1 by pi into cos n pi by n plus 1 plus cos n pi by n minus 1 and 1, the last two terms, that is 1 by n plus 1 plus 1 by n minus 1, this will become 2 n by n square minus 1. Now, this again I can substitute, simplify, that is 2 n cos n pi plus 2 n by n square minus 1. So, that now I can put the value of cos n pi as 2 n, this 2 n is there. So, 2 n can come outside, 2 n by pi into minus 1 to the power n plus 1 by n square minus 1. And I hope now it is clear why we evaluated the value of B n separately, because in the denominator you are having n square minus 1. So, from here I cannot find out the value of B 1. So, we evaluated B 1 separately, and for n greater than 1 we are finding the value of B n, and this is equals, obviously it is 0 if n is odd, and it will be 4 n by pi into n square minus 1 whenever your n is even. We got this thing. So, once I obtain this value, so now I can write down f x equals x square, f x equals x square, this equals 4 by pi into twice sin 2 x by 2 square minus 1 plus 4 sin 4 x by 4 square minus 1 plus 6 sin 6 x by 6 square minus 1, and like this way it will go, which after simplification I can write it 8 by pi into sin 2 x by, it will be 3 plus twice sin 4 x by 15 plus 3 sin, it will be 6 x by 35, and like this way it will go from here. So, I hope now that once I am doing this thing, that f x equals this is the series. So, just we have done this thing, Fourier series of f x we are defining, f x equals this, where Bn is 2 by pi 0 to pi f x sin n x dx, b by pi. Here we are writing cos x sin n x dx. From here B1 we are calculating separately, reason already we have told you. For n greater than 1, now I am evaluating this, and if I simplify, go on simplifying this thing, I am getting this result. From here Bn is this. Now, in the simplified form of Bn, I can write it as 2n by pi minus 1 to the power n into minus 1 to the power n plus 1 by n square minus 1, which from here it shows that if n is odd, the value is 0, and whenever n is even, this will be equals to 4 n by pi into n square minus 1. Therefore, for odd or even function, I am getting the value as Bn, and f x is equals to 4 by pi into twice sin 2x by 2 square minus 1 plus 4 sin 4x by 4 square minus 1 plus 6 sin 6x by 6 square minus 1, like this way it will go, and this is equals 8 by pi into sin 2x by 3 plus twice sin 4x by 15 plus 3 sin 6x by 35, and like that way it will continue. So, therefore, if we have the half range series, then how to find out the solution or how to express the function in terms of a Fourier series, we have seen that thing, and I am also hoping that you will be confident to find the solution of different problems, that is to find out the Fourier series of functions which are defined in various intervals, namely alpha to alpha plus 2 pi or minus pi to pi or 0 to pi or minus L to L or from 0 to L. In nutshell, I may have the general interval, I may have the interval in terms of pi 2 pi, that is 0 to 2 pi or minus pi to pi. I may have the interval from minus L to L with period 2L. I can find out the Fourier series of the odd function, Fourier series of the even function, and half range Fourier cosine series or half range Fourier sine series of a function f x when the function is defined in the interval 0 to L. In that case, as you have observed, we are extending the function, we are redefining the function in minus L to L. So, that in in 0 to L the nature of the function will remain same, but in the minus L to 0 the nature of the function will behave as odd function or even function. Thank you.